Good morning, children. Can you all hear me?
Yes, sir.
Right. Okay. Right. Okay. Uh, so today we have to start from the MCQ number 28. Right. Look at the MCQ number 28. A gas jar filled with a gas, capital X, was inverted and placed vertically in a beaker of water. Then it was seen that the water level inside the gas jar increases rapidly and gas X can be. Remember students, now here they have mentioned, this is MCQ number 28, right? This is about the water solubility of the gases. Water solubility. Right? Indirectly, they are asking which gas is more soluble in water here. Now they have given different gases here. As you think, what is the answer for this question? Right? They have given neon gas, nitrogen gas, carbon dioxide, and ammonia. Which one is more soluble in water? Neon, nitrogen, carbon dioxide, ammonia, among them, which one is more soluble in water?
Carbon dioxide.
Hmm? So here answer should be ammonia, not carbon dioxide here, ammonia. Remember students, they have given that a gas jar filled with a gas, X was inverted and placed vertically in a beaker of water, right? Then it was seen that the water level inside the gas jar rises rapidly. The gas X can be, right? So we know that since the ammonia gas is well soluble, now they have taken, just imagine a tube, right? A test tube. we hold, we don't have to take gas jar. So this is filled with a gas, right? And this is the beaker, right? And they have inverted this gas jar and put that one here, right? Like this. Now there will be some water level inside this tube, and this is the gas, right? In this way, this is the ammonia gas. So what will happen is, now here the pressure is very low. Since ammonia gas is well soluble in water, remember students, ammonia gas is well soluble in water. Ammonia gas molecules are dissolving in water, producing ammonium aqueous, ammonia aqueous. Or else we can say that when ammonia gas is dissolving in water, it is producing ammonium hydroxide aqueous, which is a weak base, ammonium hydroxide. And then ammonium hydroxide is separated into ammonium plus aqueous cation and OH minus aqueous anion in this way, right? But they have given the water level is rapidly increasing. Water level is rapidly increasing inside the gas jar. According to my diagram, it's a tube, test tube. The reason is when the ammonia gas is dissolving in water, the pressure created by these gas molecules, we know that students, gases can create a pressure, right? A gas inside the container is creating a pressure. So that pressure is decreasing because the gas molecules are dissolving in water. So what will happen? Then there will be a pressure difference. Since there is a pressure difference, the atmospheric pressure is greater than the pressure inside the gas jar. So what will happen? Now this is the atmospheric pressure, right? This is the atmospheric pressure created on the water level in the beaker. Then what will happen? The water level inside the gas jar is increasing rapidly. Understood? Now the ammonia gas, the most of the ammonia gas particles are dissolved in water. Right? Now just imagine here we can see ammonium aqueous, ammonium hydroxide aqueous. So therefore the water level is rapidly increasing. So here actually they have simply talked about the water solubility of ammonia. Nitrogen gas is an inert gas. Neon is also noble gas. They are not dissolving in water. Carbon dioxide can dissolve in water, but not much as ammonia. Okay. So therefore here answer should be MCQ number 28. Answer should be fourth one. Right? Yes. Answer is fourth one, ammonia. It's kind of a general question, general knowledge question too, right? Okay, shall we move to the next question? Next question is regarding the heat changes. They're asking which of the following is most likely to be the change represented by the energy level diagram? Yeah, you have learned this one in the uh, uh, heat changes also, right? Can you tell me, first of all, whether this reaction is endothermic reaction or exothermic reaction? What is your opinion? Is this endothermic or exothermic? Yes. Yalindu, you are correct. What about the others? Zainab, you are correct. Yes, what about the others? Yeah, Muhammad, your answer is correct. That's correct. Shadia, your answer is correct. Students, we know that. Yeah, Akshay, your answer is correct. In grade 11, you have learned a lesson known as heat changes associated with chemical reactions, right? Now, chemical reactions are two types. Now, I'll give you the explanation for this MCQ, MCQ number 29, right? Depending on the heat liberated, so we can consider that the reactions are two types, right? So we can say that chemical reactions are depending on the two types. Chemical reactions are two types depending on heat changes. The first one is exothermic reactions. Exothermic reactions. And the second one is endothermic reactions. We know that exothermic reactions means they can liberate heat. They are releasing heat. They release heat. An endothermic reaction means they will absorb heat. Release heat and absorb heat. Normally, we consider that the release heat is negative and the absorb heat is positive. Understood? So, actually, what will happen in the exothermic reactions, right? In exothermic reactions, what will happen when they release this heat to the outside? The temperature of the system is increasing, right? In exothermic reactions, the temperature of the system is increasing during the process, right? So, we can say that reactants, if you can remember, we learned that the reactants are converted to products and heat. This is why we consider this one as an exothermic reaction. Reactants are converted to products plus heat. A part of reactants converted to heat. Okay. Now, if you can't understand how to draw that energy diagram, it's very simple thing. We know that, students, according to this reaction, you can see which one has the greater energy, reactants or products. Actually, the part of the reactants only converted to heat. Now, you forget about this arrow. You just imagine this is equal symbol, right? Children, you assume that this arrow is equal symbol. Then reactants equal to products plus heat. Then you have to understand here, reactants, energy of the reactants are greater than energy of products. Can you understand? Energy of the reactants are greater than energy of products, right? So let me write down here. I'm using the symbol here H, R, H, P. Okay, H means actually energy, right? Here I'm representing the energy. So, reactant energy is greater than product energy. Now, if I ask you to draw the energy diagram for this one, how you can draw the energy diagram for this one? For the exothermic reactions. For the exothermic reactions, we can draw the energy diagram. As I told you, reactants energy is greater than product energy. Now, in the y-axis, it's representing energy. Then we can go for this kind of a level, which is representing the reactants, because reactants are having great energy than products, right? Then reactants here, products. So we are moving from reactants to products. Then arrowhead is towards the downward direction for this one. In this way, right? So it is releasing heat, right? Energy is released. Energy is released. From reactants to products, it is converted from reactants to products, then heat is released. Then reactants are having greater energy. Remember that. In exothermic reactions, reactants are having greater energy than the products. Remember that always. That's why the heat is released. That's why it is called exothermic reaction. Is it clear? Right. That's why it's called exothermic reaction. Now, what are the examples for the exothermic reaction that they have given in your textbook? Remember, in your textbook, they have given most of the fuel combustions, right? Combustion of fuels, methane, ethane, propane, butane, right? Hydrocarbons, all the hydrocarbons. So they actually considered as what? Exothermic reactions. I'll give you the list of examples. You remember them, okay? Because in the examination, they are asking, now look at this question. They are asking the examples they have given in the textbook. So therefore, please read the textbook and highlight those examples, right? If you have the textbook, turn to the page number 208. In the page number 208 in the textbook, they have given few examples on exothermic reactions and endothermic reactions. But don't worry, I'll give you the list of examples. I'll summarize everything here. Calcium oxide. Calcium oxide is reacting with water. Calcium oxide is quicklime. It is reacting with water and producing calcium hydroxide, lime water. It's an exothermic reaction. Then copper is reacting with HNO3, right? It's a exothermic reaction. And remember, sodium hydroxide, HCl, these are known as acid-base reactions. All the acid-base reactions are exothermic reaction. Remember, acid-base reactions are exothermic reactions. Okay. Then when the metals like magnesium, they are reacting with HCl, we can consider they are exothermic. Then combustion of fuels. Combustion of fuels, they are exothermic. Then we can say, yes, cellular respiration. That is also exothermic reaction. So remember these examples. Okay. In these reactions, they are releasing heat. Then you have to understand if the exothermic reactions are releasing heat, then what does mean by endothermic reactions? What is an endothermic reaction? In endothermic reaction, we can say that the energy is absorbed. Then the system is becoming cold. Get it? Right? Yeah, absorbing heat. In exothermic reactions, what will happen? Heat is releasing. Right? Heat released. Released. Then endothermic reactions, what will happen? In endothermic reactions, we can say that endothermic reactions, we can say, yeah. So we can say reactants are absorbing heat and converted to products. Okay. Converted to products. So therefore, here heat is absorbed. Heat is absorbed. The reactants are absorbing heat. Now I have a question for you. In exothermic reactions, I told you, since the reactants, some of the reactants are converted to heat, energy of the reactants is greater than energy of products. Then endothermic reaction, what will happen? Right? HR and HP, we can say that energy of products greater than the energy of the reactants. In this way, energy of the products greater than the energy of the reactants. Then how we can draw the energy diagram for the endothermic reactions? For endothermic reactions, we can draw the energy diagram in this way, right? So in endothermic reactions, we know that which one has the greater energy? Which one has the greater energy? Products. Products have the greater energy than reactants. Then we are moving from reactants to products in this way. Understood? So therefore, energy is absorbed. Energy is absorbed. Energy is absorbed. Right? Always remember that one. Always remember that one. Now, can you remember I told you something like exothermic reactions are having minus value, endothermic reactions having a positive heat like that, right? The reason is normally, maybe you have done the calculations in physics. When you measure the potential energy, students, we consider this one as the potential energy zero level. Potential energy is zero, right? In this level. Then all the energy values, that we measure above this level is positive and this is negative. Right? That means if you are going up, they are positive. If you are going down, they are negative. Now, even in this diagram, you can see that we are going down. So therefore, it's a negative value. So here we can see that we are going up. So therefore, it's a positive value. Okay. Right. Don't worry. You will learn about those things later when you do A levels, right? So just for knowledge. Then, right. Then one more thing, in endothermic reactions, what will happen? The system is becoming cold. And in exothermic reactions, the system is becoming, the temperature of the system is increasing, right? So what are the examples that they have given for the endothermic reactions? We can say that ammonium chloride dissolved in water, NH4Cl, ammonium chloride dissolved in water. We can see that the system is becoming cool. Yeah. I'm providing the notes. I have uploaded the notes to the WhatsApp group. Last week also I gave you the note. Then glucose is dissolving in water. It is also endothermic reaction. Okay. Glucose dissolving in water is also exothermic reaction. The next one, photosynthesis, right? Photosynthesis. We know that photosynthesis reaction is 6 carbon dioxide reacting with 2H2O, producing glucose C6H12O6. So you have learned these things in biology lessons. This is the photosynthesis reaction. So that is also endothermic, right? It will absorb heat. Actually, carbon dioxide and water, they are reacting in the presence of sunlight, okay? So sunlight means what? Energy. So those energies absorbed and then producing glucose and oxygen. Then we can say decomposition reactions. Remember students, most of the decomposition reactions, right? 95%, I would say 97% of the decomposition reactions are endothermic. Okay, generally we can say that decomposition reactions are endothermic, right? Decomposition of calcium carbonate, right? Let me write down the reaction also. Decomposition of calcium carbonate also what? Endothermic, all right? Then we can say urea fertilizer is reacting with water. That is also urea fertilizer dissolving in water is also endothermic reaction. Then we can say citric acid and bicarbonate, sodium bicarbonate. Citric acid and sodium bicarbonate. Can anyone tell me the source of citric acid? Where we can obtain citric acid? Lime. Yes, lime. Lactic acid. I'm just asking. Lactic acid. We know that acetic acid is vinegar. Yes, milk. That's correct, Mario. Correct. So please remember these examples. Now, this question is made by those examples. they have checked whether you know the endothermic reactions and the exothermic reactions, right? Please read the lesson 8, grade 11, lesson 8, heat changes associated with chemical reactions. Very, very easy lesson. And in this lesson, we are doing some calculations, Q equal MC delta T, MC delta theta. When I'm discussing the theories in the theory class, I will theory revision, I will discuss this calculation MC theta. Okay. So using this Q equal MC theta, we can discuss what calculations and everything. Okay. So you can expect these things in the theory revision. Now, when I'm starting the theory revision, let's discuss about these things, right? Yes, if I summarize what we discussed so far here in this MCQ, chemical reactions are two types depending on heat changes, right? Exothermic reactions and endothermic reactions. Exothermic reactions means they are releasing heat. When the energy is released, that means heat release, we can say the temperature is increasing. In endothermic reactions, what will happen? It will absorb heat. That means the system is becoming cold. In exothermic reactions, reactants are converted to products plus heat, so that heat is released. Then you can say that always the reactant energy is greater than product energy. So I have mentioned that one in the energy diagram, always reactants at the up and the products down. So therefore, energy is released. What are the examples for the exothermic reactions? Remember these examples. Calcium oxide is dissolving in water. Copper is reacting with nitric. Sodium hydroxide and HCl, acid-base reactions. Then sodium. We can say that even metals, sodium, potassium, rubidium, first group, second group metals, when they are dissolving in water also, exothermic reactions are taking place. Magnesium is reacting with HCl. Combustion of fuels, right? And the cellular respiration. So all of them are considered as exothermic reactions. In endothermic reactions, what will happen? Reactants are absorbing energy and products are produced. So that means the reactant energy is lower than the product energy. That means we are starting from the products, right? Product energy is higher, reactant energy is lower. Then energy is absorbed. So as examples, we can say that ammonium chloride dissolved in water, glucose plus water. When glucose is dissolving in water, it is endothermic reaction. Photosynthesis, decomposition of calcium carbonate, urea fertilizer is dissolving in water, and citric acid and sodium bicarbonate. Okay, right. That's the summary. Now let's move to the MCQ number 28. They have given which of the following is most likely to be the represented by the energy level diagram given. By looking at the energy level diagram, this is endothermic reaction. Can you see that? Look at the diagram carefully. In the diagram, they have given the product energy is greater than reactant energy, then definitely it is endothermic reaction. Okay, so they are asking which one is the endothermic reaction? Dissolving glucose in water. Just now I told you, right? Combustion of hydrocarbon methane. Combustion of hydrocarbon methane is exothermic. Reaction between zinc and hydrochloric acid. Magnesium HCl. Magnesium is a metal. Zinc also metal. They are exothermic reactions. Neutralization between sodium hydroxide and hydrochloric acid. Children, I told you all the acid-base reactions are what? Exothermic reactions. So second one, third one, and the fourth one, they are exothermic reactions, but the first one is endothermic. So therefore, MCQ number 29 answer is first one. MCQ number 29 answer is first one. Right. Shall we move to the next one? Next question. MCQ number 32. I think it's a calculation. Okay, let's move to the calculation. Two reactions used to prepare the gases hydrogen and carbon dioxide. So it's difficult to keep the examples on mind. You can't say like that. You have to at least remember a few examples. Okay, you can do it. Why you are saying that you can't do it? You can. Maybe it's difficult, but you try. Okay. You have to study little by little. Understood? Nothing to worry. First of all, try to remember at least three examples, right? Three examples from exothermic reactions and three examples from endothermic reactions, right? First of all, memorize those three from each. Then later, study another three. Okay. It's difficult only. That's the way, right? But you have to do it. You should not give up. Okay, Amir. Zinc is reacting with HCl to produce zinc chloride and releasing hydrogen. Calcium carbonate is reacting with HCl to produce calcium chloride, water, and carbon dioxide. So they have clearly mentioned the two reactions. They're asking what is the mass of calcium carbonate that should be reacted to obtain an amount of moles of carbon dioxide gas which is equal to the maximum amount of hydrogen gas obtainable from 32 grams of zinc. Okay, so it seems to be a very difficult calculation. Am I right? Or easy for you? Right? Did you get the answer for this one? Anyone did this calculation before I do this one? Anyone here? Anyone got the answer? Okay, let's see. All right. Okay, look at this. Zinc reacting with HCl to produce zinc chloride H2. Calcium carbonate is reacting with HCl to produce calcium chloride H2O carbon dioxide. What is the mass of calcium carbonate that should be reacted to obtain amount of moles of carbon dioxide gas which equals to the maximum amount of moles of hydrogen gas obtained from 32 grams of zinc, right? Okay, let's do the calculation. This is MCQ number 32. Zinc is reacting with HCl to produce zinc chloride and hydrogen gas. Children, they have given relative atomic masses of all the elements. Now, in the exam paper, they are giving those values. So, therefore, you don't have to worry about them. Can you see that? They have given the relative atomic masses. Hydrogen is 1, carbon is 12, oxygen is 16, calcium is 40, zinc is 64, right? Now, they are asking what is the mass of calcium carbonate that we should take in order to release carbon dioxide moles that is equal to the maximum amount of hydrogen gas moles obtaining from the 32 grams of zinc, right? The question now, the first thing is the calculation is okay. We can do the calculation. We know it. But the thing is, reading the question and understanding is another challenge for us, isn't it? Hmm? Keep the calculation a little bit away, will you? Now, look at the question. Look at the question, how they have given the question. It's a little bit complicated, isn't it? It's not a typical question that they're asking. So you have to understand the question. Remember, when you do the exam paper, read the question carefully. Okay, if you don't understand the question, it's okay. Take your time and read the question 2-3 times until you understand that. So let's calculate how much of hydrogen gas moles that we can obtain from the 32 grams of zinc. Okay, now let's move to the calculation. Look at this. First of all, I have to balance the reaction. In order to balance the reaction, we have to put. Then they have given the mass of zinc. It is 32 grams, right? Then can you remember we had an equation like simple n equals simple m over capital M in calculations, right? In grade 10, we learn this kind of equation. Can you remember that? Under the quantification of elements and compounds, right? Grade 10, we learn this kind of equation. Simple n equals simple m over capital M. So what is this simple n? Simple n means number of moles, right? What is simple m? Mass of the substance, right? What is capital M? Capital M is molar mass. Molar mass, molar mass, or else we can say relative atomic mass. If it is a compound, it is relative molecular mass, right? Can you understand? Now, as an example question, let's do an example question. Before we go for that one, I'm asking you how many moles? How many moles are there in 8 grams of oxygen? And they have given oxygen's relative atomic mass is 16. How do you do the calculation? Use the equation. Simple n equal simple m over capital M. Mass is given as 8 grams. Yeah, it's easy. Then what is the molar mass? Now, relative atomic mass is 16 means molar mass is 16 grams per mole. Relative atomic mass and molar mass, only the difference is unit. Then 16 grams per mole. Grams will cancel off. Here 8, here 16 also divided by 8, then half. Children, per mole is going to the numerator as mole. That means answer will be 0.5 moles. Okay. So this is a simple example question. Is it clear? Right? In this way. Now, let's apply that one for this question. Right? Now, if you apply this for the question, simple n equal simple m over capital M, then simple n equal Mass is 32 grams. What is the molar mass of zinc? They have given 64 grams per mole. Grams will cancel off. 32 v 1 and here 2 are 0.5 mole. So zinc number of moles are 0.5. Zinc number of moles are 0.5. Is it clear? 0.5 moles. Then what we supposed to do? Now we have to find out hydrogen moles. Hydrogen moles. How do you find out the hydrogen moles? Now, if the zinc moles are 0.5, what is the hydrogen moles obtained from the reaction? If the zinc moles are 0.5, what is the number of moles of hydrogen obtained from the reaction? How do you find that? I ask you a simple question. Number of zinc moles are 0.5. Then what is the number of moles of hydrogen that we can obtain? Children, now we know that these are the coefficients, right? Now look at the coefficients. 1 is to 2 is to 1 is to 1. 1 mole of zinc is reacting with 2 HCl to produce 1 mole of zinc chloride, 1 mole of H2. Okay. 1 mole of zinc reacting with 2 moles of HCl, right? In order to produce 1 mole of zinc chloride and 1 mole of H2. Then tell me 0.5 moles of zinc is reacting to produce how much of it H2? Very simple. 0.5. Yes, right? If 1 mole of zinc is producing 1 mole of H2, 0.5 moles of zinc producing 0.5 moles of H2. Raise your hand those who understood that logic. Very simple thing. It's not a big deal. Right? If you have any doubts, put your doubts in the chat box. What are the doubts? Didn't understand. Okay, right. Now, we calculated the number of moles of zinc. Okay. We calculate the number of moles of zinc. According to the reaction, we know that zinc is reacting with HCl to produce zinc chloride and H2. But when you balance the reaction, you can realize 1 mole of zinc reacting with 2 moles of HCl to produce 1 mole of zinc chloride, 1 mole of H2. According to the reaction, right? According to the reaction stoichiometry. 1 mole of zinc is producing 1 mole of H2. Then 0.5 moles of zinc is producing 0.5 moles of H2. Got it? 0.5 moles of zinc is producing 0.5 moles of H2. That's the point. Then we have obtained anyhow number of moles of hydrogen 0.5 according to this calculation, right? Better you do this calculation, right? Please do the calculation. Take your time, and if you have any doubts, ask. Tell me if you have any doubts. Right, okay. Are we done? So why is zinc and H2 taken as 0.5 moles? Yeah, that's why I explained you. It's depending on the, right? It's depending on the reaction. See, according to the reaction stoichiometry. Now for an example, look at this one and look. Aluminium is reacting with HCl to produce aluminium trichloride and H2. In order to balance the reaction, we can put 2 here, 3 here, and 2. Otherwise, the reaction is not balancing, right? We have to balance the reaction in this way. Okay. Now, just imagine I am going to add here. Right. I'm going to add 2 moles of aluminium. According to the reaction, right? According to the reaction. How much of HCl reacting with that? Okay, answer me. How much of, yes, 6. Then how much of aluminium trichloride is produced? 2. How much of hydrogen gas produced? 3. Is it clear? According to the reaction stoichiometry. Stoichiometry means, students, okay, forget about that term. These are reaction coefficients, right? These are now aluminium is reacting with 2 to produce 2 aluminium trichloride and 3H2. The coefficients, right? We are balancing. We are balancing the reaction and we are using the coefficient. Now just imagine I have used 1 mole of aluminium. Then depending on the proportionality, right? Tell me how much of HCl should react. If 2 aluminium is reacting with 6 HCl, 1 aluminium is reacting with how much of HCl? 3. Simple. Then tell me how much of aluminium trichloride should produce according to this proportionality? 1. Then how much of hydrogen gas should produce? Answer for this one, that one very carefully. Everyone. Yes. What is it? Yalindu, what is the answer? Yalindu, what is the answer? One 1.5, right? 1.5. Okay. Is it clear? Now just imagine I'm going to add 4 aluminium. Then how much of HCl? No. Situmya, you are wrong. You're wrong. Yes, exactly. 12. Right? Look at the ratio, right? 2 is to 6. That means 1:3, 4:12. Do the simple maths. Then what is aluminium trichloride? That is also 4. What about hydrogen? What about hydrogen? Hydrogen is 6. So you have to follow the ratio. And that's how I took that. When zinc is reacting, 1 mole of zinc is reacting to produce 1 mole of H2, means if 0.5 moles of zinc reacting, 0.5 moles of hydrogen is produced. Right? Okay. Is it clear? Right? Done. Now let's move to the question again. Go back to the question. So they're asking what is the mass of calcium carbonate. That should be still not clear. Okay, right. Let's do some calculations. Definitely. Now, this is about how much of moles reacting. Okay. Right. This is about how much of moles reacting. When you consider this reaction, 2 moles of aluminium reacting with 6 moles of HCl to produce 2 moles of aluminium trichloride and 3 moles of H2. When you balance the reaction, we put these kind of coefficients, right? Front of the compounds. So these are the number of moles, the ratios they are reacting. Then you have to understand clearly, if I put 1 mole of aluminium, according to that ratio 2:6, how much of HCl should react? React 3. How much of aluminium trichloride should produce? 1. How much of H2 produce? 1.5. If I double this one, if I double the aluminium number of moles as 4, then all the other number of moles should be double. Then HCl should be 12. Aluminium trichloride should be 4. Hydrogen should be 4. Then the reaction that we consider, zinc and H2, the ratio between zinc and H2, the reacted number of moles ratio is 1:1. Then if something is 0.5, if zinc is 0.5, then the other one is also 0.5. So very simple thing, right? I'm still wondering that why you are thinking so much about it. It's a very simple thing, simple maths. Okay, right. Hope you will do these calculations better when we discuss more questions. Okay, no need to worry. Right. Now, go back to the question again. Then they have given what is the mass of calcium carbonate that should be reacted to obtain an amount of moles of carbon dioxide which is equal to the maximum amount of moles of hydrogen. Okay, now we calculated hydrogen gas amount moles as 0.5. Then the equal amount of carbon dioxide is 0.5. Then they're asking what is the mass of calcium carbonate that should react with HCl to produce 0.5 moles of carbon dioxide, right? So the reaction is, we know that here the reaction is calcium carbonate is reacting with HCl to produce calcium chloride, carbon dioxide, and H2O. In order to balance the reaction, we can put 2 here. So carbon dioxide moles are 0.5. Now tell me, right? Look at the coefficients 1, 1, 1, 1. Okay, now tell me What is the calcium carbonate number of moles? If carbon dioxide moles are 0.5, according to the ratio, calcium carbonate and carbon dioxide, you can see the ratio is 1:1. Then tell me calcium carbonate number of moles should be 0.5. Very simple. 0.5. Then use the equation. Use the equation, simple, and number of moles equal to mass divided by the molar mass. Okay. Then here calcium carbonate number of moles will be 0.5. Now you have to find out the molar mass of calcium carbonate. How do you find out the molar mass of calcium carbonate? Calcium is 40, carbon is 12, oxygen 16 into 3 grams per mole. Do the summation. 40 plus 12, 16 into 3 is 48. So the summation is 100. Calcium carbonate is 100 grams per mole. Now apply for the equation and find out the mass, right? Simple M equal simple N capital M. Number of moles are 0.5. Molar mass is 100 grams per mole. Per moles will cancel off. 0.5 multiplied by 100 grams. What is the answer? 0.5 multiplied by 100 grams. Answer, the decimal is shifting 2 times. 1, 2, 50 grams. This is the mass of calcium carbonate that should be reacted with HCl to produce equal amount of gases as hydrogen equal to carbon dioxide. Okay. That's why I told you the calculation is not easy, but so you have to do these kind of calculations, right? If you have any doubts, you can ask me before we move to the next MCQ. Then MCQ number 32. MCQ number 32 answer is 50 grams. So calcium carbonate has 0.5 moles and carbon dioxide has 0.5 mole, but calcium carbonate and carbon dioxide not same. Yeah, they are not same. They're not same. Okay. Number of moles can be same. According to the reaction, calcium carbonate number of moles reacted is same as carbon dioxide number of moles produced. That is according to the reaction. Understood? But they are not same. Yeah. Number of moles, only number of moles are same. Right. Okay. Now let's move to the next MCQ. Students, just asking, children, I'm just asking you. Raise your hand. Those who feel like still struggling in the calculations, chemical calculations. That means you're thinking that's I need uh, a proper revision for the calculations separately, that kind of a thing. Okay, right. Okay. Okay, you can expect that one in the theory revision. Okay. So let's put another theory revision day. I'll let you know about that one. Right. Okay. Now see, when you do one past exam question, how many things that you have learned? Can you realize that? When you do a question, right? When you do the review for that question, how far we can learn? We are still in the first paper, right? We didn't go for the other papers. Then just imagine in these 10-year papers, how much knowledge, how much of things, how much of exam tactics you can learn. Okay. Definitely you have to do the past papers, model papers, term test papers, provincial papers, everything. Understood? Right. Now, next one, MCQ number 33. In the form of a thin layer, metal X is applied on the iron sheet, capital A, and metal Y is applied on the iron sheet, capital B. Right? Then a small scratch was made at the center of both sheets. Later, rusting has spread rapidly on capital A, but B has not been subjected to a considerable damage. The metals X and Y respectively can be. What is the answer for this one? in the form of a thin layer. Again, I'm reading the question. Metal X is applied on the iron sheet, capital A. Metal Y is applied on the iron sheet B. A small scratch was made at the center of both sheets. Later, rusting has spread rapidly on A, but B has not subjected to a considerable damage. Okay. B has not been subjected to a considerable damage. The metal X and Y respectively can be. What are they? As you think. Okay, put your answers in the chat box. We can discuss. Yes, you are correct. Yalindu, you are correct. Right. Now, remember, students, in our lessons in electrochemistry, we are learning a part like rusting. Okay. So, corrosion of metals, especially we are discussing about iron. Okay. So, what will happen is when rusting, the iron metal is converted to Fe2 plus cation. It is an oxidation. Okay. So, therefore, what we have to do is in order to reduce this rusting, we are using some methods known as cathodic protection or else uh, anodic protection. Okay. So, I'll discuss about the anodic protection here. Now, you have to remember this one. Look at this one. MCQ number 33. So we are talking about iron rusting. Okay. Now, when iron is rusting, what will happen is Fe metal is converted to Fe2 plus aqueous and 2 electrons are released. Remember, students, this is considered as an oxidation. Oxidation. Okay. This is considered as an oxidation. Oxidation means it is releasing electrons in this way. It is an oxidation. Right. And we call this one as anodic reaction. This is known as anodic reaction. Then there is another reaction taking place in this way. 2 water reacting with oxygen gas by taking 4 electrons to produce 4 OH minus. We consider this one as reduction, oxidation and reduction, and this is what we called as cathodic reaction. Anodic reaction and cathodic reaction. Okay. Now, normally we know that in the atmosphere, oxygen and water vapor is there, right? When oxygen and water vapor, that means H2O gas, in the atmosphere, are together, iron rusting is taking place, as mentioned above. Okay. So iron rusting means, students, the metal iron is oxidizing and producing Fe2 plus. Okay. So that's what meant by iron rusting. So when you consider the overall reaction can be written as 2H2O liquid reacting with oxygen, 2Fe solid, producing 2Fe2 plus aqueous, and 4OH minus. Now, instead of these two, if you want, you can write down this is ferrous hydroxide, in this way FeOH twice solid, in this way. Okay. Then this ferric hydroxide produce is reacting with atmospheric oxygen to produce Fe2O3, H2O, solid 2H2O. So this is what we call rust. Reddish brown color, rust. Malakada, right? Rust. Understood? Formula of rust is actually, we can say, formula of rust Fe2O3 X H2O. The number of water molecules can be changed. It depends. Now, these are the chemical reactions taking place in the iron rusting. Okay. Now, in your textbook, they have given a separate section under electrochemistry about this rusting process, corrosion of metals. So, Now they have given that the two iron plates are there. So how we can prevent this rusting? That's the important thing. Now these are the chemical reactions of rusting. So you can remember these things. You can study these things. You can just know about it. Now how we can prevent this one? That means what we can do, right? So there are two methods actually. One is cathodic protection and the other one is anodic protection. Cathodic protection means actually what we are doing is galvanizing and the making alloys, right? In cathodic protection, what we will do is we are connecting that iron with high reactive metals in the activity series, aluminium, magnesium, like high reactive elements than iron. Then the iron metal is protected. That is known as cathodic protection, right? And the anodic protection is, right? Let's discuss about anodic protection. In anodic protection, what will happen is iron is coated with paint to prevent it from contacting with the factors necessary for rusting. So tell me, what are the factors necessary for rusting then? What are the two main factors necessary for rusting, as we discuss? Anyone? What are the factors necessary for rusting? I mentioned oxygen and water vapor. Oxygen and water vapor, right? We can say oxygen and water vapor. These are the factors necessary for rusting. And to prevent it from becoming the anode, right? So what we do is here, as examples, we can say applying low reactive metals, like tin and copper, or else we apply oil, grease, enamel paint, so those kind of things. Okay, anodic protection. Understood? So that means we have to prevent that iron is becoming the anode, because when iron is becoming the anode, students, what will happen? This metal iron is converted to Fe2 plus. It's oxidizing. We have to prevent that. Okay. Now let's see this iron, tin, copper. They are located in activity series. See, this is the activity series. So you can see iron is here and tin and copper here, right? So we are coating them with this tin and copper. The reason is their reactivity is low. That means we are reducing the now just imagine we have iron plate, okay, or iron rod or iron plate or whatever it is, a material which is made by iron. When you coat that iron with, right, when you coat that iron with a paint which is made by these low reactive metals, what will happen? The iron is prevented, right? So then, even though water vapor is there, even though oxygen is there, these copper, tin like elements are not reacting because iron is protected now. Iron is protected. Understood? That's why we are coating them. So in order to prevent iron rusting, we can use a method. Right now, look at this is the place, this is the position where the iron is located in the activity series. Okay. Then you can use any of the metals like this, tin, lead, copper, or anything like that. And when you coat that iron with this metal, iron is prevented because these are slowly reacting with water. These are slowly reacting with oxygen. Then iron is prevented, right? This is what we considered as anodic protection. In the cathodic protection, what will happen is, in the cathodic protection, the iron is coated with these kind of highly reactive metals, magnesium, aluminium, sodium like magnesium, aluminium, zinc like metals. Then they are reacting with the water and oxygen, and iron is prevented. Understood? So both the methods can be used. Cathodic protection and the anodic protection. Right? Any doubts? What are the doubts you have? In order to prevent the corrosion of iron, rusting of iron, we can use two methods. One is cathodic protection and the other one is anodic protection. In the cathodic protection, what we will do is, we are coating high reactive metal than iron on the metal plate, iron metal plate. Then those elements are reacting with water and oxygen, and iron is prevented. The other method is low reactive metal than iron is coated on the iron metal sheet. Then these things are not reacting with water or oxygen. Then also iron is prevented. That is known as anodic protection. Now let's move to the question. Here they have mentioned in the form of a thin layer metal X is applied on the iron. Using high reactive metal is cathodic protection. Yes, Yalidu? Yes. Iron sheet A and metal Y is applied on the iron sheet B. A small scratch was made at the center of both sheets. Later, rusting has spread rapidly on A. Right? Rapidly on A, but B has not been subjected to considerable damage. The reason is the small scratch is enough. Now we know that, just imagine the metal is coated with tin. Tell me, students, if the metal is iron, metal is coated, metal sheet, iron sheet is coated with tin, means is it cathodic protection or anodic protection? Anodic protection. Because tin is low reactive metal than iron. A small scratch is enough, right? What will happen? Suddenly the iron is rusting. Iron is reacting. So therefore that capital A should be definitely tin. But you can see that the other one, even though there is a small scratch, right? It doesn't matter. There is no considerable damage in B. Then it is zinc, because zinc is already reacting with water and oxygen. Then iron is safe. Iron sheet is safe because zinc is highly reactive. Therefore, the answer is first one. Okay. Now I'm asking a general knowledge question. According to this question, which one is more suitable? Cathodic protection or anodic protection? Which one is more suitable? Cathodic protection, right? Yes, cathodic protection. Let's discuss about the cathodic protection then. Okay, now you know about the anodic protection, right? Cathodic protection means, right? Look at this one. These things are very interesting concepts, okay? Cathodic protection. This is known as sacrificial protection. Because these metals are sacrificing themselves, no? Zinc, magnesium, aluminium, they are sacrificing themselves in order to protect iron. Sacrificial protection. When a highly reactive metal act as anode, and sacrifice itself to prevent iron from rusting. It is called cathodic protection. Metals like aluminium, magnesium, zinc act as anode and iron act as cathode. We can give examples. Galvanizing. In galvanizing, students, what we are doing is we are using magnesium. A magnesium coat is there before the iron, then making alloys. So these are the examples. Okay. So cathodic protection is better than the anodic protection, right? So is iron the only metal is protect? No, 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 no. We can use other metals also, right? In order to protection, in order to prevent the corrosion of the other metals also, we can use this method. Not only iron, but in our O-level science syllabus, they have specifically mentioned about the corrosion of iron, rusting of iron. Okay, we can use this method for the other metals also. The main reasons that alloys are produced so is this corrosion of the metals. Okay, do you want this note from the big iron rusting? Quickly copy down this. I'm uploading the note to the WhatsApp group, so therefore nothing to worry. Yeah? Right, okay. Are we done? So what have you given as overall reaction? Overall reaction means now can you see that cathodic reaction and anodic reaction, there are two types of reactions. Okay. So the difference between cathodic and anodic reaction is one is releasing electron and another reaction is taking up electron. Okay. One is oxidizing and the other one is reducing. One is releasing electron is oxidation and the other one is taking up electron means reduction. So when you combine these two reactions, you can get the overall reaction. Okay. So that means let's discuss about that one under the theory revision. Okay. Don't worry about it. Right. Okay. Students, let's take a small break. Now time is 9:53. I'll start the class at 7, 10:10. Okay. Take a break. Right, okay, let's start. Right. Now, look at the next question. So the next question they're asking, it's a calculation again. 600 grams of water at temperature 80 degrees Celsius. Today class will be conducted until 11, okay? Since we started class at 8, 8:10, I will be doing the class until 11:10. Okay. 600 grams of water at temperature 80 degrees Celsius were added to a vessel containing 200 grams of water at 0 degrees Celsius. What is the final temperature of the mixture? Okay. So the specific heat capacity is given. Assume that the vessel doesn't absorb heat. Students, this question is related to heat lesson in physics. Okay, so therefore, let me skip that question for now. Huh? Now, let's move to the MCQ number 36. ABC are three sets of simple cells. One is zinc, one is copper electrode, zinc and copper electrode. B, zinc and copper electrode both are there. And in the other one also zinc and zinc electrode, diluted sulfuric acid. Okay. So they're asking in the external circuits of the cells ABC above, the electron current flows only in. What is the answer? A and B. Some says A and some says B. Some of them are saying A and B both. Right. Okay. Now, in electrochemistry, right? Electrochemistry lesson, we are learning about electrochemical cells. Right. Remember, electrochemical cells means they are converting chemical energy into electrical energy. Chemical energy into electrical energy. Right. If I draw the simple cell produced by zinc and copper electrodes, right? In this way. So they are connected to ammeter, right? This is zinc metal and this is copper metal. And we are using diluted sulfuric solution. Okay. We consider here zinc is the anode and copper as the cathode. Right. So zinc and copper, they are considered as electrodes. Electrodes. And what is the electrolyte? Electrolyte solution. And ions present in the solution. We have a zinc electrode, copper electrode, and the electrolyte is diluted sulfuric acid. H plus OH minus N sulfate. Right. Now, in the cell, when the cell is working, remember students, near the anode, okay, the zinc is removing electrons and producing zinc 2 plus. Can you remember, removal of electron is known as oxidation. Then near the cathode, what will happen is H plus is taking up electrons and producing H2. H2 gas. In this one. And overall cell reaction, when we write down overall cell reaction, what we have to do is we are combining these two equations. What we have to do is left side is added to the left side and the right side is added to the right side. Look at this. Zinc solid, 2H plus aqueous, 2 electrons. Zinc 2 plus aqueous, 2 electrons, and H2 gas. So here 2 electrons will cancel off. And then zinc solid, 2H plus H2 gas. This is the overall reaction. Right? Electrons and electrons will cancel off. See. Okay. Is it clear? Now in electrochemical cell, we consider that students, now zinc is oxidizing and releasing 2 electrons. No? Then electrons are gathered around the zinc in this way. Therefore, we consider zinc is negatively charged. Okay. Then these electrons are starting to flow towards the copper, direction of copper in this way. Then current is flowing for the opposite direction from copper to zinc. Is it clear? Then tell me students, when the cell is working, electrons are flowing from which one to which one? Anode to cathode or cathode to anode? In the electrochemical cell, when this cell is operating, the electrons are flowing from anode to cathode or cathode to anode? Anode to cathode, remember that. Because anode metal is oxidizing and releasing 2 electrons now. Then these electrons are gathered around that anode, then these electrons are flowing through that circuit, this kind of a circuit. Understood? So therefore, flowing for that direction. Then the current electricity is passing from copper to zinc. That means cathode to anode. We can say a positive terminal. That is the positive term. Positive terminal and negative term. Can you understand? Right? This is what happens. This is what happens. In an electrochemical cell, anode becomes the negative terminal, negatively charged one. Cathode becomes the positively charged one in electrochemical cell. So this is the electrochemical cell that they have given. If you note down this one, quickly note down this quickly. Kavin, 34 answer that they have given is second one. 34th one answer is second one. Okay. Right. Okay. Are we done with this one now? Now this is the electrochemical cell which is made by copper and zinc. Now let's move to the question. Look at the cell. Which one is correct here? Zinc, copper, diode sulfuric. First one is correct. Capital A is correct. Is capital B correct? What do you think? Is there any defect in capital B? What do you think? Yeah, so in capital B, you can see that the copper electrode and zinc electrode both are touching. So therefore, it cannot be the correct one. In capital C, you can see both of them are zinc electrode. It's also not correct. So therefore, here first one is the correct one. Right. Then in 2025 paper, all the chemistry questions are completed. So how many questions we did so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 questions from chemistry units. Okay. Uh, the questions are not hard. The calculation is a little bit hard, but other theory parts also okay, manageable. But some good questions are there. Okay. Raise your hand those who understood the things that we discuss in the MCQ paper. Before we move to the essay paper, do you have any doubts regarding the MCQ questions that we discuss? Right. Okay. Now let's move to the chemistry questions in the essay paper, second paper. Right. Look at the third question. Third question is based on the think ionization energy and the electronegativity concepts are given. Let's see. Right. Yeah, that is the third lesson, no? Structure of matter. Mhm. Now, the question concerns the elements from sodium to chlorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, belonging to the third period of the periodic table. Okay. Capital A, figure 1 and figure 2 show graphically how the electronegativity and the first ionization energy vary against the atomic number sodium, magnesium, aluminium of the elements stated above. So they have given electronegativity sodium, magnesium, aluminium. Complete the above two graphs indicating approximately the points relevant to the other four elements. Okay, for the other two elements only they're asking. Right. Now, let's discuss about this ionization energy and the electronegativity concepts. Now, essay paper question number 3. Right. So, under the periodic properties, we are discussing about first ionization energy, electronegativity, melting point and boiling point. Right. So let's discuss about the first ionization energy. When we discuss about the first ionization energy, there is a graph you have to remember with a zigzag variation. Remember, always in the first ionization energy graph, helium is at the top. Then here comes lithium. Then we have beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Look at that. It's a variation, zigzag variation. Okay. Very high, go down, go up, two times go up, one time down, two times go up. Okay. Now here you can see one time go up, one time go down, two times go up, one time go down, two times go up. Right. So these are the second period elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Understood? So normally oxygen and hydrogen are at the almost same level. In the ionization energy graph, oxygen and hydrogen both are at the same level, almost at the same level. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Got it? So in the third period also, you can see the same variation. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, argon. Is it clear? Then potassium and calcium come down like this. Potassium, calcium. So this is the ionization energy graph for the first 20 elements. Okay. A rough diagram. A rough diagram. Is it clear? Let's see what is the graph that they have given in your resource book. In your textbook, sorry. Look at this. Now you have to analyze this graph very carefully. Yes, yes, yes. You have to remember the exact pattern, and that pattern is not that much difficult to remember. Okay, children, it's not that much difficult to remember. So we didn't ask you to remember the values. Okay, I have pasted it in my wall. Yeah, good, really good. That's the way that you have to study, right? Always remember that zigzag variation. That zigzag variation is always helpful for us to quickly go for the answers, right? If you do A-level chemistry, I'll let you know. Right? So, in our A-level chemistry, the first lesson is atomic structure. There we are learning about this first ionization energy graph again. And we are learning second ionization, third ionization graph energy also. Right? There are some reasons why now we are discussing why helium comes here. Okay. Why neon comes here, argon here. So lithium, sodium, potassium, why comes? Why now we are expecting that lithium, beryllium is somewhere here, but why suddenly beryllium is increased there? So we are discussing those reasons A level. Okay. So I leave that curiosity to you all. So if you do A level maths or bio, definitely you will learn these things. Here now for our paper, so you have to remember this zigzag variation, right? It's very simple. One time go up, right? We can say one time we go up, one time down, two times up, one time down, two times up. Suddenly drops for the third period. One time up, one time down, two times up, one time down, two times up, suddenly drops. So remember in that way. Understood? And you have to be very careful. Now, if they ask you to compare the two different period wise elements, oh, look at this. Beryllium, magnesium. Can you remember beryllium, magnesium? Both are in the same group, no? Second group. Okay. Then beryllium has larger ionization energy than magnesium. The reason is the radius. Beryllium is too small than magnesium. Therefore, it's hard to remove an electron. That's why its ionization energy is high. Look at all the group wise elements: nitrogen, phosphorus, fluorine, chlorine, neon, argon, right? Lithium, sodium. Always the first element in the group has the great ionization energy. Down the group, ionization energy is decreasing. Can you remember? Down the group, ionization energy values are decreasing. Okay. Maybe you haven't learned. They have given the values also. See, in your textbook, they have given the ionization energy values also. Then you have to remember relative variation also. Okay. Let's compare the relative variation. According to the graph, according to the data values, which one has the largest ionization energy value? Okay, which one has the lowest? Potassium. Then calcium. No, it's not calcium, potassium, then sodium. Right? After that, lithium. Okay. After that, aluminium. Then calcium. Hmm? After that, magnesium. Then silicon. Then boron. Yeah, beryllium. After that, sulfur. Right. Phosphorus. Then we have carbon. Yes, carbon. Next one is chlorine. So the next one is hydrogen, right? Then oxygen, nitrogen, argon, fluorine, neon, helium. For this direction, ionization energy increases. Now you have to remember these relative variations. Okay, because students, we don't know in which way they will ask the questions in the exam. You have to prepare for that one. Okay, you find a method, you can do it. Okay, it's okay if you can't remember this one, leave it, doesn't matter, right? They won't ask these kind of difficult questions, but in case if they ask, you should be able to answer for this one also. That's what I'm asking you to remember this one. Clear? So anyhow, but it's a must, you have to remember these variations, exact variation. Okay, definitely you have to remember that variation for sure, right? Then these are the things that you have to remember under ionization energy. Okay, so they have given this one in your textbook also, right? Please refer the textbook variation and thing. Okay, and remember down the group. Now, when you consider a group wise, atomic radius is increasing. Okay, now lithium, sodium, potassium, rubidium, cesium. Down the group, atomic radius increases. Therefore, ionization energy increases. Ionization energy decreases. Because students, ionization energy means the minimum energy required to remove an electron from the valence shell, right? So therefore, when the size is becoming larger, it's easy to remove the electron. So therefore, ionization energy is, so you can see that one from the data values, lithium, sodium, potassium. Okay. Right. Then electronegativity. What do you know about the electronegativity? First of all, what does mean by the electronegativity? Can anyone explain, give the definition for the electronegativity? Right. What is the definition for the electronegativity? Hmm? Anyone? Electronegativity means ability of an atom of an element to attract electrons on another element. Yes, Yalindu, you are correct. Okay. So I would say like this, ability to pull the electron cloud when they are chemically bonded toward itself. Okay. Yes, Kavin, you are correct. That's correct. The ability to pull bonding electrons toward itself when a covalent bond is made with another element is known as electronegativity. Right. Let me revise the definition again. Okay. You have learned these things in grade 10, but it's okay. The ability to pull bonded electrons towards itself when a covalent bond is made with another element is known as electronegativity. So in order to measure the electronegativity, we are using something known as Pauling scale of electronegativity. Right? According to the Pauling scale, now hydrogen, lithium, sodium, potassium. So there is a pattern. I'll teach you that pattern. You can remember these values using this pattern. Maybe you have learned in your theory classes also. Check whether you have learned this pattern. First period, second period, third one, fourth one. First group, second group, third group, fourth group, fifth one, sixth one, seventh one, and the eighth one. The most electronegative element is what? The most electronegative element? Fluorine. The most electronegative element is fluorine. Right? Then the value of it is 4.0. And now it's easy. From here to here, always the values are decreased by 0.5 by 0.5. 0.5 by 0.5, the values are decreased. 3.5, 3.0, 2.5, 2.0, 1.5, 1.0. In that way. Understood the pattern? Fluorine is the highest electronegative element. It's 4.0. In the second period, for fluorine to lithium, the values are decreased by 0.5 by 0.5. Right? Never knew this. Not never knew. You never noticed that. Okay. You have to notice these things. Now, yeah. Then here, when you consider fluorine and chlorine, chlorine's value is 3.0. One value lesser than fluorine's value. Sulfur value is 2.5. One value less than that. You have to remember sulfur and chlorine that way. Remember, hydrogen and phosphorus both are same 2.1. Hydrogen and phosphorus both are same 2.1. Phosphorus to sodium values are decreased by 0.3 by 0.3. 0.3, 0.3, 0.3, 0.3. That means silicon is 1.8, aluminium 1.5, magnesium is 1.2, sodium is 0.9. Okay, in this way. Right. In your textbook, are these the values they have given? Let's see. Three, 2.5, 2.1, 1.8, 1.5, 1.2, 0.9. Okay, no? The values are decreased 0.3 by 0.3 from phosphorus to sodium. Done? Okay. Then potassium and calcium, you have to remember in this way. That means potassium is one value lesser than that of sodium. Calcium is one value lesser than of, sorry, two values of lesser than the magnesium, 1.0. Okay. So you can remember the electronegativity table in this way. Okay. And neon and argon, helium, neon, argon, we are not discussing about the electronegativity for them because electronegativity means The ability to pull the electrons when they are chemically bonded. So helium, neon, argon, like noble gases, are not forming chemical bonds. And remember, students, the most electronegative one is fluorine. Second electronegative one is oxygen. According to the Pauling scale, nitrogen and chlorine both are same. But remember, uh, this is the Pauling scale. No, there are so many scales to measure the electronegativity. So therefore, actual value of chlorine is greater than the nitrogen value. That means you just imagine chlorine is something like this 3.08 and nitrogen is something like 0.31, 3.01. So chlorine is greater than nitrogen. Okay, you remember that. Maybe in the Pauling scale they are same. In the Pauling scale they have given up to first decimal. No, they haven't mentioned the second decimal, right? That's why we are telling nitrogen and chlorine both are same. Now you have to remember what are the elements having the same electronegativity. Nitrogen and chlorine, they have same. Then you can see, did you notice lithium and magnesium, lithium and calcium, they have same. Then beryllium and uh, aluminium, they are same. Then we can say hydrogen and phosphorus, they are same. Okay. Sulfur and carbon, they are same. Sulfur and carbon, also same. Got it? Anything else? So likewise, there are some elements having the same electronegativity values also, right? Okay, this is what you have to remember under the electronegativity. Okay, ionization energy and the electronegativity. As a summary, we have to learn about these things. Let's discuss this one under the theory revision again. I'll discuss these things. Okay. Look at this one. Is this clear to you? Yeah, Tisali, I'll let you know about the theory revision very soon. Now in August month, now in this month only we started the class now. Probably in September, okay? Let's start the theory revision class, okay? Definition for the electronegativity, the ability to pull bonded electrons towards itself when a covalent bond is made with another element is known as electronegativity. So before electronegativity, what are those circles that you show that ionization energy increases on? Circles means that means you're telling this one. This is atomic radius. Now down the group, atomic radius is increasing. Now lithium, sodium, potassium, down the group radius is increasing, right? Atomic radius is uh, increasing down the group. That's what I have mentioned here. Right. Shall we move to the question then? In the question, they have given. Now you can draw the variation. Yeah, definitely. All the notes will be shared in the WhatsApp group. Okay. Last week also I shared that one. You can refer those things anytime in the group. Okay. In the WhatsApp group, everything is available. I will upload this note after the class. So now for this one, now electronegativity is what? Increasing. Okay. So it's gradually increasing. Then continue the line. Sodium, magnesium, aluminium. Not straight though. Right. Something like that. Okay. So this is silicon, phosphorus, sulfur, chlorine. You don't have to draw that one to the correct scale. Okay. They are not expecting like that. They are only checking the variation, gradual increment. That's all. Huh? If you want the values here, I'll write the values again. If you can remember, uh, phosphorus was 2.1. This is 1.8, 1.5, 0.2. This is 0.9, right? Sulfur 2.5, chlorine 3.5. Yes, it is important to remember the values in the Pauling scale. Please remember them, okay? Then the ionization energy. So how that ionization energy is varying? We can say that aluminium, sodium, magnesium, aluminium. Can you remember? One time up, one time down, then two time up, two times up. We can go somewhere like here. Silicon, phosphorus, sulfur, chlorine. Okay. Silicon, phosphorus, sulfur, chlorine. In the marking scheme, they have mentioned sulfur should be above silicon. Silicon should be above magnesium, right? If not, you will not get marks. In the marking scheme, they have given sulfur above silicon, silicon above magnesium. See, they have checked that much sensitive. They have checked the graph that much sensitively. Therefore, you have to remember the variation of the graph properly. Sulfur should be above silicon and silicon should be above magnesium. Got it? Right? Okay. So likewise, you have to remember the. Okay, children, you understood everything that we discussed today? All okay? Is everything clear? What are the doubts? How about the today's session? Was it useful? Right. Okay. Then these are the things that we have to discuss today. Then we successfully completed the second session also. In the next class, I will be discussing the remaining essay questions. I will upload the note to WhatsApp group and I will upload the recording also. So did everyone watch the first session recording? Those who missed? Okay. Then I will upload the note and the recording, right? Okay. Then let's meet on the next week class. Then next Saturday also, morning 8. We will be discussing the remaining questions. Okay. Until next Saturday, then study well. Okay. Now examination is getting closer. Now December means we are in August, September, October, November. Only 3 months. Just 3 months. We have to get ready for the exam. Okay. Okay. I'll upload the 2024 LL paper also, right? To WhatsApp group. Okay. Let's meet on next week class then. Until then, bye bye. Have fun.